Fusion Mobile, quality e-learning experience on the go.
Good day, you're welcome to Fusion Mobile e-learning class. My name is Bolaji. I'm here to speak on the subject mathematics. And the topic before us today is mensuration of three-dimensional figure. Mensuration of three-dimensional figure. What are these three-dimensional figures we want to consider in this topic today? We want to consider cone, the frustum of a cone, and pyramid. We want to see the shape and how we can measure them. How we can measure them. Now, let's take example. A right pyramid consists of a square base of side 13 centimeter. Example 1. A right pyramid consists of a square base of side 13 centimeter, 4 isosceles triangle whose angle side are 27 centimeter each. Calculate its volume. Calculate its volume. This question is very technical. We have to first know shape of pyramid before we start to solve the questions. But before I solve question on pyramid, let me first go through the frustum of a cone. What is a frustum? Because every of this shape has definition. Frustum is when the top of a cone is removed by a plane which is parallel to the base. The shape remaining is called frustum of a cone. Frustum of a cone. That is, when the top of a cone, let me show you the shape of a cone. Now, this is the shape of a cone. It has another shape like this. Now, in form of a house. Look at the house we normally build when we were in village. It's the shape of a cone. The biro we use, the pencil we use, is the shape of a cone. Now, if we remove the top of this side, it means that we are talking about this shape. It means it's called a frustum. So a frustum means when the top of a cone is being removed by a plane. When this side is just chopped up like this by a plane, then it is called a frustum. The remaining shape that remains is called a frustum. That is, after which it has been removed, it will not be parallel to the same base. It will parallel to the same base, forming a frustum. I want us to solve this example under frustum before we now move to pyramid. Because pyramid and frustum, they are related in one way or the other because they are three-dimensional figure. Let us first consider this frustum so that we can solve the pyramid. Now, the figure below, I want to show you this figure. The figure below shows the frustum of a cone. Whole bottom and top radii respectively are 12 centimeter and 8 centimeter. This is the frustum. It said the radii, that is the radius, this radius here, with this radius here, you know that this radius is smaller to this radius because this is forming a radius. They are 8 centimeter, that is the bottom 12 centimeter and the top is 8 centimeter. This is the radius of the small frustum of the top of a frustum and the bottom of a frustum. Now they gave us a height of 13 centimeter. This is 13 centimeter here. The question that follows say, calculate its curved surface area. Curved surface area. 1, 2. They say we should calculate the total surface area. Three. The last thing is volume. These are the three things we are going to be considering when we are dealing with a frustum. This is a frustum. Now, we are going to look for the curved surface area, we are going to look for the total surface area, and the volume. Number 1, the curved surface area is what we are going to look for. Curved surface area. Now, before we look for curved surface area, we have to make this frustum to be a full cone. We have to make it to be a full cone so that we can measure the cone accurately and to compare the height of the smaller top that have been chopped off. Now, we are going to draw this and extend the top that have been chopped off up very well. This place is 12 centimeter. This place is 13 centimeter. This place is 8 centimeter. Now we will extend it. This place is called H. This is the first H, 13 centimeter they gave us. When we extend this one up to form a cone, it meets at this point called vertex and form a cone. So this place is small h, this place is the big H. Fine. How do we now find this H? We have to first label all these points so that you'll be able to understand what you are saying. Therefore, let's call this place A. This place is called A, B, and C, D. Good. I'd like us to still label a few points here. We'll call this place to be Phi, and we'll call this place to be Y. Good. Now, we can now solve this question now because we have extended this frustum upward. We have extended this frustum upward. Now, how do we find our H? Is the first thing we have to bear in mind. Let us use our knowledge of similarity. That is the smaller cone Phi AB. Let's consider Phi AB. This is a cone, and compare with the bigger cone, which is what? Phi CD. Good. When we do that, we'll be able to find our height H. Be able to find our height H. Therefore, compare cone Phi AB and Phi CD. Compare cone Phi AB and Phi CD. Good. We now have H over 8. This is the radius equal to this one, H plus 13 over 12. So as for us to find our height H. Now, how do we find our height H? Is by cross multiply. We cross multiply to find our height H. Therefore, 12 times H equal to 8 bracket into H plus 13. Now we now have 12H equal to 8H plus 8 times 13 in your calculator. I guess it's supposed to give you 104. That's 8 times 13. That is 8 times 3, 4. You carry the remaining 1, which is 2. 8 times 1, that's 8 plus 2, 10. 104. Now we have 12H, we have 8H. we have to collect the like terms, which is 12h minus 8h equal to 104. We have 4h equal to 104. Therefore, 4h equal to 104. Divide both sides by 4. 4h over 4 equal to 104 over 4. 4 here 1 cancel. 4 here 1. 4 in this place. We have 2. Remainder what? 4 here 2. Is remainder 2. 4 here 8. H is equal to 28. So H, our H is equal to 4 in 24 is going to give us 6. 6. Correct. Check your calculator. 4 in 24 will give us 6. So we have 26 centimeter. That is 4 divided by 104. 104 divided by 4. 4 here 1. 4 here it remains 2. Carry your 2 here. 4 here 6. 26 centimeter. Our height is 26 centimeter. This small letter h that we extend upward is 26 centimeter. Good. Once we have found our height to be 26 centimeter, we can proceed. Because without us finding the total height, we can't find the slant height. And once we do not find the slant height, we can't find the curved surface area. We can't find the curved surface area. Once the slant height is not being found, this is the slant height. This is the normal height. We can't find the curved surface area. So now, how do we now proceed? Hence, we discover that the height of phi AB is 26 centimeter. The height of phi CD is now going to be 13 plus 26. Height phi CD is 26 plus 13. That is h plus 13, which is equal to what? 39 centimeter. While height phi AB is equal to 26 centimeter. For the largest cone here, it gives us 39 centimeter. For the smallest cone, it gives us 26 centimeter. We'll find our height now. We can now begin to find our slant height of the cone. Because without finding the slant height of the cone, we can't get the curved surface area. The curved surface area. Now, how do we find our slant height of the two cones? This is the first slant height, and this is the second slant height. Now, I told us about what is called Pythagoras theorem from the beginning. When we remember, when we're dealing with trigonometry, SOHCAHTOA, trigonometry, and Pythagoras theorem. This is the point at which you apply Pythagoras theorem, because we all know that all our slant height is always larger than the other two sides. That was what Pythagoras told us. Now, let us now find our slant height for the smaller cone and for the bigger cone. This is the smaller cone, this is the bigger cone. How do we find our slant height for here? Now, I want us to name this place to be x. The middle point here is called x. Let this place be called x. So we now have phi xp. Phi sp. Now, from the phi sp, we found our height to be 26 centimeter, and this our base here to be 8 centimeter. So our h, which is called slant height, h can be found, which is phi b. Now, consider phi sp. Consider phi sp. That is phi sp here, which is this phi sp. We have our sp to be 8 centimeter. We have our phi x to be what? 26 centimeter. Then our phi p is question mark. We now use Pythagoras theorem to find it. Therefore, phi p square equal to our sp, xp is 8 centimeter square, plus our phi x, which is what? 26 centimeter square. So phi p square equal to, what is 8 square? Check your calculator. Our 8 square is what? 64, plus what is 26 square? Check your calculator. The 26 square is supposed to be 676. 676, 676. Then phi p square is equal to 64 plus 676. Check your calculator. Supposed to give us 740. 740, correct. 740. Our phi p will now be root 740. Root 740. What is root 740 in your calculator? Quickly, because we have to move fast. That's 27.2. 27.2 centimeter. 27.2 centimeter. So here we find our slant height for the small cone to be 27.2 centimeter. We have to find our slant height for the bigger cone, which is very simple. Consider phi yd. Consider phi yd. Consider phi yd. Consider phi yd. Now, we know that our phi y is this h, which is 26 centimeter, plus 13 centimeter. That's the height. It is phi yd. Consider phi yd. Then, what is our phi d? This is phi d. Phi d square is equal to phi y square plus cy square and dy square plus dy square. This is dy. Phi y square. Now, phi d square is equal to what is phi y square? That is 39 square plus what is dy square? Dy square is 12 square. How do we get 39 square? Our 39 square is this h 26 plus 13. That is 26 plus 13 will give us 39 centimeter. That's the slant height for the bigger cone. So therefore, if you have 39 square plus 12 square, what is the answer? Check your calculator. 39 square will give us what? 1,521. 1,521. 1,521 plus 144. Then the answer is what? Phi d square is what? 1,521 plus 144 will give us 1,665. 1,665. Therefore, phi d square is equal to root 1,665. Our phi d is equal to, what is the root of 1,665? Yes. The root of 1,665, check your calculator very well because we must not make mistake. 40.8 centimeter. 40.8 centimeter. 40.8 centimeter is our phi d. Now, our slant height of this bigger cone is 40.8 centimeter. 40.8 centimeter. Our first slant height for phi AB is 27.2 centimeter, while the slant height for the bigger cone is 40.8 centimeter. 40.8 centimeter. Now we can now calculate our curved surface area of this cone because we've extended the fulcrum upward to find the height. The two heights is being known. The slant height of each of the cone is being known. So it's easy for us to now find our curved surface area for each of the cone. Our curved surface area. So what is the curved surface area? What is the formula for finding curved surface area of a fulcrum? Because the question asks us to calculate curved surface area, total surface area, and the following. Now, the curved surface area of a fulcrum is measured or used a formula called pi RL. Pi RL. Pi RL. That L means what? Slant height. Slant height is equal to L. R is equal to bigger radii. Then pi is 22 over 7. Pi is 22 over 7. We have slant height equal to L. R is the bigger radius. And pi is 22 over 7. So this is the formula to calculate for curved surface area. Curved surface area of a fulcrum. Of a fulcrum. Therefore, how do we now have the curved surface area of the cone here, another cone here? How do we solve it? It's by using this formula. Pi RL, which is the for the radius for the bigger fulcrum, minus pi RL, radius for the smaller fulcrum. And we've calculated their slant edge, which is here. This is their slant height. This is their slant height. Therefore, let us substitute our value. Now, for the bigger fulcrum, we have our pi to be what? Pi to be 22 over 7 times, what is the radius for the bigger cone? Is 12 times 12. And the slant height that we calculated, what is slant height? When we were using Pythagoras theorem, is 40.8 minus. Then our pi is 22 over 7. Then what is our radius? 8 centimeter from the questions. Then what is our slant height? Is what? Times 27.2. Very easy. You can see the importance of us to calculate slant height in fulcrum. It's very important. Without calculating the slant height, we cannot get the curved surface area of the fulcrum. So therefore, substitute your value into it. 22 over 7 times 12 times 40.8. 22 over 7, which will now give us 1,000. I think it's so. Check the calculator very well. 22 times 12 times 40.8 over 7 supposed to give us 10,771 over 7. 10,771 over 7. 10,771 over 7.2. Okay, minus 22 times 8 times 27.2 over 7. The answer is supposed to give us 4787.2 minus 4787.2 over 7. Therefore, use your calculator to divide 10,771.2. What is the answer? Check your calculator. 1,538.74. 1,538.74 minus 4787.2 divided by 7 will give us 683. 683.89. So 1,538.74 minus 683.89, and the answer is 854.85. 854.85. That is our curved surface area. Remember, when we are dealing with area, you need to put your units. So the unit to here is square centimeter. Square centimeter. That is the curved surface area. That is the curved surface area of a fulcrum. Now, we are not yet through. We have to move forward because the question says calculate the curved surface area So since our beginning, we have been dealing with curved surface area. Now it is total surface area we want to find. We have to find the total surface area, which is very easy. What is the total surface area? The area is equal to the area of the circular of both the top and the bottom plus the curved surface area. We will find our curved surface area to be 854.85 square centimeter. That's our curved surface area plus the area of a square. That is, this is the circular of top and this is the circular of bottom. Very easy. We have been given this radius here to be 12. We have been given this radius here to be 8. So we can now find both the area of the circular of top and the bottom. Both the area of the circular of the top and the bottom. Then how do we do it? What is the area of a circle? That is our question. What is the area of a circle? The area of a circle is given to be what? Pi r square. That's the area of a circle. So the total surface area, which is what we are considering now, total surface area of a frustum is equal to total surface area is equal to area of the circular of both top and bottom plus curved surface area. Now, area of the circular of both top and bottom is equal to pi r square plus pi r square plus the curved surface area. Remember the curved surface area, we said that it's going to be pi rl plus pi rl. Pi rl plus pi rl. That is how we are going to solve it. Now, we've gotten that our pi r square, which is 12 centimeter, which is 22/7 times r square, 12 square plus pi 22/7 times 8 square plus our curved surface area to be 854.85 square centimeter. Very easy. Now, you are going to write 22 times 144/7 plus 22 times 64/7. Then we now add it with the curved surface area plus 854.85. And our answer is what the total will give us the total surface area. Add 22 times 144/7 plus 22 times 64/7 plus 854.85. Once we have gotten it, is our total surface area. And the answer that you're supposed to get in your calculator, check your calculator, is 1508.56 square centimeter. That's 1508.56 square centimeter. I guess you are correct. Check your calculator very well. When you had this plus 854.85, will give us 1508.56 square centimeter. So the total surface area. The total surface area is the area of both the top of area of circular of both top and bottom. That is the area of the circle of this place, pi r square plus pi r square plus the curved surface area that we found. Remember, the curved surface area is pi rl. That is the area of the bigger cone, pi rl, plus the area of the smaller cone, pi rl. You add it together, you are going to get 854.85 square centimeter. And the total surface area is that you had the area of both area of the circular of both top and bottom plus the area of the plus the curved surface area, and that's how we get our total surface area, which gives us 1508.56 centimeter. I know that you are following me, but if you still have a shady mindset, I would like you to rewind back so that you can be able to understand this total surface area and curved surface area. Now, I want us to solve these questions correctly by moving forward to what is called volume of a frustum. Volume of a frustum. How do we calculate the volume of the frustum? It's very important. Now, the volume of the bigger cone minus the volume of the smaller cone will give us the total volume of a frustum. What do I mean? What is the volume of a cone? Remember, we have the volume of a cone because the volume of a cone must be given. We have two cones in this diagram because we have extended the height and we have found the height. So, therefore, we have two cones. This is the smaller cone, this is the bigger cone. We have to find the volume of the smaller cone and the volume of the bigger cone. But what is the formula of a cone, of the volume of a cone? The formula for volume of a cone is given to be 1/3 pi r square h. 1/3 pi r square h is the formula of volume of a cone. Now, the volume of the frustum is what we want to calculate from the question. Volume of a frustum is given to be 1/3 pi r square h minus 1/3 pi r square h. That is, for the bigger cone, this is for the bigger cone, and this is for the smaller cone. Therefore, 1/3 times 22/7 times what is this one's bigger cone, which is 12 square, times h. That is 26 plus 13 times 39 minus 1/3 times 22/7 times what is our radius? Our radius is 8 square. And what is our h? Our h is 26. Therefore, we have to calculate for the value of this bigger cone and the value of this smaller cone. When we calculate the value of the bigger cone, we subtract it from the volume of the smaller cone. And the answer to this question has been rightly stated that check your calculator so as to find out our answer. Now, the volume of the bigger cone is given to be 5,883. 5,883.43. 5,000, check your calculator. 5,883 point what? 43. Good. Minus what is the volume of the smaller cone? Check your calculator. I'd like you to press it very well to have accurate answer. 1,743 point what? 1,743.24. 1,743.24 minus 5,883.43 minus 1,700 and what? Check your calculator. 43. Let us be accurate. 0.24. So when we minus it, what is our answer? 4,140. 4,140.2 centimeter, cubic centimeter. Because we are dealing with volume here, its measurement is cubic centimeter. So we have 4,140.2 cubic centimeter. That's the volume of this cone. That's the volume. When we extend the cone up, when we extend the side to meet at the vertex to form the normal cone. So that's the volume of the frustum that we calculated. I am confident that you understood differences between curved surface area, total surface area, volume of a frustum, and this cone, especially, which is a three-dimensional figure, has been unraveled. So anywhere you see questions that involve frustum, use this idea and solve the question, and I believe you will get your accurate answer. Let me give you a few evaluations so as to conclude this three-dimensional figure that involves a cone before we move to the pyramid. Thank you. I know you've understood the volume, curved surface area, and total surface area of the frustum related to cone that we've calculated. I want us to proceed to the pyramids. To the pyramids. Pyramid is one of the three-dimensional figures that we're going to see today. Let's consider this example. A right pyramid consists of a square base of side 13 centimeter and 4 isosceles triangles. Now, pyramid is in three types. We have rectangular pyramid, we have square base pyramid, we have triangular pyramid. But the one that we want to consider in this three-dimensional figure is a square base pyramid. A what? A square base pyramid. Now, let us consider this example. As I've said, a right pyramid consists of a square base of side 13 centimeter and 4 isosceles triangle. So this is a type of pyramid that have square as its base. We have other one that has rectangle as its base. So this one is a right pyramid who has square base, and then it has 4 isosceles triangle with equal side, each 27 centimeter. Now, we have to draw it out so that we can understand it very well. We can draw the square like this, and also we can slant it like this. Now, how will this thing form a pyramid? I'd like you to look at my hand so that you can get this shape of a pyramid. Now, look. Now, this is a square base. Now, we want to draw the pyramid as it moves. Good. You can see now this is a pyramid. They meet at this vertex here. This is a square base pyramid. Now, the question said a right pyramid consists of a square base of side 13 centimeter. Now, that shows they have 13 centimeter. 13 centimeter. Good. Now, they now said 4 isosceles triangle whose sides are each 27 centimeter. Whose sides are each? So we have 27 centimeter. That's the side of each of the 4 isosceles triangle. Then we have to calculate one total surface area. calculate total surface area. That's the number one thing they ask us to calculate, total surface area of a square base pyramid. How do we calculate total surface area? Now, they say each of the side of this 4 is 27 centimeter. This place is 27 centimeter. 27 centimeter, 27 centimeter, 27 centimeter. This place also is 27 centimeter because there are 4 isosceles triangles. We have one triangle, 2, 3, 4. 1, this is 1, 2, 3, 4. So we have 4 isosceles triangles. Good. Each of the sides is 27. 27, that side that faces that side. This is 27 that faces this side. The other one is 27. So each of the sides is 27 centimeter. I believe you understood this diagram now. Side, the base, 13 centimeter each. Now, how do we calculate total surface area of a square base pyramid? The total surface area of a square base pyramid is given to be sum of the base and the area of the 4 triangles. You sum the base and the area of the triangle. How do we calculate the area of the base of this pyramid? Area of the base. Area of the base is equal to 13 times 13. 13 times 13 will give us the area of the base. And the area of the base is given to be 169 square centimeter. 169 square centimeter. That's the area of the base. Now, we want to calculate the area of the triangle. The area of the triangle. But before then, I would like us to give letters to all the square base of this thing. Now, let's name this one S. This is P, Q, R. P, S, Q, R. And this top that they meet at the faces, we call it phi because they call it faces. So this place is called phi. Faces. Good. Now, we are going to now calculate the area of the triangle because we are finding the area of the base. How do we calculate the area of a triangle that have the same side? There is a formula that is called Eros rules. Eros rules. I want us to use Eros rules because they have the same side. They have the same side. 4 triangles that has the same side. And the Eros area is given to be root x bracket x minus a. You close the bracket, x minus b. You close the bracket, and x minus c. Now, how do we find our x? So far they have the same side. They have 3 sides that are equal. If 3 sides is being given, then we can calculate the area of a triangle using Eros rule. Now, use Eros rule. Use Eros rule. If we use Eros rule to calculate the area of the given size of a triangle, the Eros rule is equal to root x bracket into x minus a bracket into x minus b bracket into x minus c. That's the Eros rule. Now, but how do we find our x? Our x is given to be, we are being given the side, and the side is this. 13 centimeter is given to be this side, 27 centimeter is given to be this side, another 27 centimeter which is equal to a plus b plus c over 2. A plus b plus c over 2, which is the x formula. So a plus b, which is 27 plus 27, 27 plus 27 plus 13 over 2. And the answer is what? Check your calculator. We have 67 over 2, which will now give us 33.5. 33.5. That's our x. Now we've known our s. We can now substitute our s into each of the following. Knowing fully well that our a is 27, our b is 27, then our c is 13. Use the arrows rule because of the side being given. If the two sides were not given, then we begin to use Pythagoras theorem. But the side has been given. Therefore, we substitute our value. Our a is equal to 27 centimeter. Our b is 27 centimeter. Our c is 13. So we substitute our value to be like this. That's 33.5 bracket into 33.5 minus 27. Then open the bracket, 33.5 minus 27. Then you open the bracket, 33.5 minus 13. When we substitute the value finish, then we root it. What is our answer? 33.5. You open the bracket, 33.5 minus 27 will give us 6.5. Then you open the bracket for this one. This also will give us what? That is 33.5 minus 27 also, which altogether will give us 33.5 times 6.5 times 20.5. Then all in the root. Please, I want you to check your calculator so that we can find the answer. The answer is supposed to give us 170.3 centimeter. 170.3 square centimeter. 170.3 square centimeter. That's the arrows rule to find the area of the square of the base. That's arrows rule. Now, after we have found this area, we have to add it with the area of the base. That will form the total surface area of the pyramid. You have the area of the base, sum of the area of the base, and the area of what? Of the side of the triangle, the four isosceles triangle. Therefore, the area of the four triangle, because we've gotten the area of this side using Ero's formula, and we have four sides. Knowing fully well that it has four sides, so we have to use the four side and multiply this by 4 to get the area. Therefore, because it is 4 isosceles triangle, remember when we say 4 times 170.3 square centimeter. When we multiply 4 times 170.3 square centimeter, then what is the answer? Use your calculator to confirm your answer. The answer is supposed to give us 681.4. 681.4 square centimeter. That's for the area of the triangle. For the area of the isosceles, 4 isosceles triangle. 4 isosceles triangle. 1, 2, 3, 4. 4 isosceles triangle. This is number 1 isosceles triangle, number 2, number 3, this one, and number 4, the other side. That's making it 4 isosceles triangle. Now, after which we found our area of the 4 isosceles triangle, the total area, total surface area of the pyramid is equal to area of the base plus area of the base area of the base plus area of the 4 isosceles triangle, which is equal to surface area of the pyramid is area of the base. We have 169 square centimeter plus area of the 4 isosceles triangle. What is the area of the 4 isosceles triangle, which is given to be 681.4 square centimeter? And the answer is 681.4 plus 169. We have 0.4 here, we have 0, we have 5, we have 8. Now we have 850.4 square centimeter, 850.4 square centimeter. That is the total surface area of the pyramid. 850.4 square centimeter. Total surface area of the pyramid is area of the base plus the area of the 4 isosceles triangle, which gave us 850.4 square centimeter. Now that's the area. We are not yet through with the questions. We have to move forward by finding the volume of the pyramid. There is formula for finding the volume of the pyramid, and the volume is given to be 1/3 times base area times height. 1/3 times base area times height. Area, okay, area of the base is 169 square centimeter. That is 13 times 13. That's the area of the base. Now, how do we calculate the volume of the base? The volume of the base is calculated to be 1/3 times base area times what? Height. The volume of the base is equal to 1/3 times base area times height. 1/3 times base area times height. How do we calculate our height? Now, that's where we now begin to use Pythagoras theorem. We have to consider triangle PQR. PQR. Consider triangle PQR. So if you consider triangle here, PQR, we have the triangle to be given to be like this. We have 13 centimeter. Then where is our Q and where is our R? Knowing fully well that this is the longest side, then our PR must be here, our Q must be here. Yes, because PR is the longest, and that's what we are going to calculate for. We already know our PQ to be what? 13 centimeter. Absolutely correct. So QR is 13, then PQ is what? 13 centimeter. Now, to find PR, use Pythagoras theorem. Pythagoras theorem, which is given to PR square is equal to 13 square plus 13 square. PR square equal to 13 square plus 13 square. That will give us, that's 169 plus 169. PR square is equal to 169 plus 169. That's 338. PR is equal to root 338. And what is our PR? Root of 338, use your calculator to find it. The answer will give us 18.39 centimeter. So here is 18.39 centimeter. 18.39 centimeter. Now we have gotten our PR to be 18.39 centimeter. We are not yet through. Because we have already calculated that our PR is the height, because it's the longest side. This is the height, is assumed to be the height. So therefore, if we have gotten our PR to be 18.39 centimeter as our height, therefore we can now calculate for the volume of the base. Volume of the base, which is given to be the volume of the pyramid, which is given to be for area 1/3 of the base area times height. So we knew our height to be 18.39 centimeter. Our height is 18.39 centimeter. Our base area is equal to 169 square centimeter. Then the volume of the pyramid is equal to 1/3 times, what is our base area? 169. What is our height? 18.39, which is equal to 169 times 18.39 over 3. And the answer is what? 169 times 18.39 divided by 3. Use your calculator quickly. Use your calculator quickly. Good. Absolutely correct. When you use your calculator, you get the right answer. That will give us in cubic centimeter. So check your calculator. The answer to it is 1035.97 cubic centimeter. That is the volume of the square base pyramid. With this, I'm confident that you'll be able to solve questions that is related to three-dimensional figures, especially the one that involve cone, frustum, and pyramid. Thank you. I would love to see you in the other class.